Numpy. So when I call Numpy, Numpy is basically numerical Python. So num stands for numerical, py is Python. So if you'll see all the files, whatever files that you create in Python, in Jupyter Notebook, they end with ipynb. So py is Python, nb is notebook, I is I don't remember right now, but pynb is Python notebook. So any file which is ending with .ipynb or file ending with .py is a Python notebook on which you are working. So NUM suggests that it's numerical. So any numerical operation, any numerical function that you want to work on, we can use NumPy easily. All the numerical operations, even trigonometry, you can calculate sine theta, cos theta. You can solve quadratic equations. You can solve uh, geometry problems. You can work on any number of mathematical operations using NumPy. So what NumPy is? It is numerical Python, and it is a inbuilt library, or you can say a package. Like yesterday, Uday mentioned that we have something called turtle. It's a package. Similarly, we call it library in Python. So it's also a library in Python. So NumPy, whenever you want to in short, whenever you want to perform any numerical operations, make use of NumPy. All things that we have done earlier, addition, subtraction, multiplication, everything that can be done easily by NumPy. We have a lot of functions, lot of variables, lot of keywords in NumPy that can be used to perform any such kind of operation. So any object, any array is something which is so NumPy is basically used to work with arrays. Arrays are something, these are matrix. What is an array? So array is something, it is a like you can say a structure. So we have an array, just like let's say we have a list. So array is a array of elements in a row. So these are the indexes. Array works with, again, every counting starts with 0. No matter whatever it is, when you are talking about Python, every indexing starts with 0. So array is something where a set of elements are clubbed together in a single place. That's called an array. And NumPy, the array that is formed using NumPy, is called a NumPy array. Simple. And we also call it as ND array. ND, sorry. It's an ND array. So any array, that is, when we are creating an array also, we create it like ND array. So that's how we create arrays in NumPy. We'll create those arrays. So arrays are used a lot due to less execution of time or high processing speed and less memory consumption. So whatever functions, whatever applications that we have done earlier in Python, those are either more time consuming, they might be consuming more memory, and the speed is a factor. It's not an optimized thing, but using NumPy, it is much more faster. It takes less memory. It executes in a very short span of time. So how do we if your Jupyter notebook doesn't have NumPy in it, so the first step is how to install NumPy. So to install NumPy, what we do is we say exclamation mark, we have pip install NumPy and run it. So it says requirement already satisfied, NumPy is already there in my packages. If it is not working for you, then you have to install it. This is the way how to install NumPy. how to import the library numpy. So how do we do that? We take import numpy. That's it. But if you want to use numpy or something, we provide it a alias also. How do we do that? Import numpy as np. Like you remember, we used to do the same thing. We used to give column aliases in SQL. As karke, we used to define the column as something. Let's say I'm taking count of elements in a particular column. So I would say count in bracket star, and I would mention as. So that is an alias, so that it gives a name to it, so that I can use it in a better way. Rather than using numpy everywhere, now I can use np as a keyword so as to access anything in my program. So I'll run it, and I can do either ways. If I'm using this, then everywhere I would have to use like numpy dot something, right? But now I can use np dot something like that. Understand? So that's why we provide an alias for an ease of use. Fine. Here np is an alias or a nickname for numpy keyword. It is just a name for the keyword numpy. That's it. It's not some fancy thing, or it's not. You can give it anything. You can give it x also. Fine, it will work. But the common norm is use np. Np is a short for numpy. So understand, it's a common terminology that we use, but you can use anything, but better use np as an alias for numpy, because if you use something else, other coders who would be working on your code won't understand what that alias is. They'll have to go back to the entire code and check what xyz, whatever alias you have given. So better practice is to give it as np as numpy nickname, or sorry, alias. That's how we call it. So in numpy, as I mentioned, that there are various arrays in numpy. So we have different dimensions of arrays in numpy. What are those dimensions? We have 1D array, we have 2D array, and we have 3D array. Fine. Sorry?
No, I was just repeating that 3D array.
Okay. So over here, what is a 1D array? A 1D array looks like any array is basically, it looks like a list, but it is actually not a list. You understand my point? How a 1D array looks like? A 1D array looks like it's in two parentheses, which is a small brackets, and then we have a list kind of bracket, which is a square bracket, and we have 1, 2, 3, 4. So this is a 1D array. What is a 2D array? A 2D array is something which is an array of 1D array. Understand? We have two 1D arrays in 2D array. So an array of 1D array is called a 2D array. How it is defined? Let's say I have 1, 2, 3, 4, comma, I have 10, 11, 12, 14, anything. But it should match. If it has 4 elements, it should also have 4 elements. So how it is basically represented? When I'm going into Python, how it is represented? When I'll print a 2D array, it will look like this. So anything, when your Python notebook becomes heavy, when you have a lot of code in your Python notebook, see, it keeps on working. रुक जा भाई. What nonsense. Okay. I guess I have to. Yeah. So what happens is how it is represented, actually how it works, how it looks like. So this is how a 2D array looks like. It's a stack. You understand? It's a stack. It's one above the other. Just like you have stacks of egg crates, egg shelves. So it's a stack of an array. You have a 1D array, you have another array under it. So like it's like there's a layer of array which is a 1D array, 1D list. There's a list over here, but it's in the form of an array. You have another layer under it. So that forms a 2D array. Fine. When
So it's like a 2 into 2 matrix.
yeah, it's a 2 by 2 matrix. Correct. It's a 2 by 2 matrix. So now what a 3D array is? It's the same thing. It's just an extension of everything what we are doing over here. So an array of 2D array is called a 3D array. So what happens is there comes another extension, there comes another layer. This becomes, there would be another layer, another line of 2D array, which would be like this. So this is 70, 30, 20, 10. So this forms, so this is a 2D array, the highlighted part. I have another 2D array. So an array of 2D array, I have a 2D array, I have another 2D array. That makes it a 3D array. So and see, this is 1D array. This is 1D array. When I add one more 1D array to it, it becomes a 2D array. Now, this thing is a 2D array. So, this is over here. This thing is a 2D array. When I add another 2D array to it, it becomes a 3D array. So, an array of 2D array is 3D array. An array of 1D array is a 2D array. And 1D array is 1D array. So, it's a single dimension. So, that's how we work on this front. Let me put it as like this. So that's how 1D, 2D, 3D arrays are diversified or identified. So let me just do it like this, so that once you read also you'll get to know what it is. Fine. This is how 1D, 2D and 3D arrays are defined and how they look like actually in Numpy. I'll show you how these are created. Let's say I need to create a 1D array. Let's say I define it as array 1 as 1D array. So how to create that thing? nd.array. I define the array over here directly. Let's say the same array. Let's say 1, 2, 3, 4. Fine. Oh, sorry. Equal to np.array, not nd.array, because np is the alias for numpy. So this is how we would be writing each and everything when we are working in numpy. np dot, everything would be followed after np. Everything we'll write, it will be followed by np. Now let's check out the type of array. Type of ARR1. Just like we are checking the type of other elements, we check list, set, dictionary, string. Similarly, type is a keyword to check the data type. So it says it's a numpy nd array. See, every array is a nd array in numpy. Now let me create a two-dimensional array. I'll print also, sorry. Let me print also this thing below. So ARR1. So it gets printed like this. Now let's say I'm creating another array which is 10, 20, 12, 11. Let's say we are creating this one. I'll give it as array 2. Let me print arr2 1 2 3 4 1 2 3 4 bracket closed np array field elements must be 2 or 3 tuples. Okay, it has to be a tuple. I cannot give it individually, I have to provide it in a square in parenthesis. Fine. What is the error over here? np.array 1 2 3 4 1 2 3 4 1 2 3 4 over here. Okay, let's check this thing out first, why it is not getting created. Field elements must be 2 or 3 tuples. Got 10 1 2 3 4 5 6 7 8. How there 10? Okay, let's check it out. 2D array in Numpy. Let's check the documentation only, how it is created. Escape. We installed it. np.range array. Okay, so this is how it is created. That's not a problem. Okay. Okay, now I get it. So once we are creating an array, you have to define the entire set. See over here, in NumPy array, in 1D array, we are providing this entire thing in square brackets. So when you are providing a 2D array, you have to combine it in a square bracket. You have to put this entire thing in square brackets. So this is one 1D array, this is another 1D array, and this entire set forms your 2D array. Get my point? When these two things combine together, they form a 2D array. So ARR2. See, this is how, like I told you over here, a set of 1D array below another array. So this is 1D array, another 1D array, that makes it a 2D array. Again it will be ND array, NumPy ND array. Now let's create a 3D array. How to do that? Now there won't be any error. So when I'm doing this thing, I'll pick up this thing, this entire thing, with a comma, put another array over here, and this would be, let's say, anything. Let it be same only, not a problem. I don't think so this should create a problem. And one 2D array, another 2D array. Again there's a problem. Okay, I get this thing. This should be in brackets. So ARR3. So this is how you get your 3D array. This is how a 3D array is represented. Clear? So I have a 2D array, I have another 2D array.
Simple.
Right? So this is just a basics of how you work with an array. Now, let's say I'm taking ARR2. So what does ARR2 look like? Array2 looks like this. Let's say I want to access only the first element of array2. So I'm indexing over it. Remember how we did indexing in lists, dictionary, sets and tuples? Same way we are doing indexing over here. So when I'm accessing ARR2, so the 0th index, it will pick that 1D array from it. Understand? Let's say I want to access the second element of it. So I'll get 10, 20 and 11. 12, 11 as the second index. Now what if somebody says, okay, you have ARR2 as a 2D array, find out what is the second element of the first index. Get my point? So this is the first element of first index, this is the second element of first index. So ARR2, what I'll do is, this is my first index, I am accessing the second element of the first index. So it gives me 2. Why this is 1? You will ask me, Avin, you are saying second element you have to access, why didn't you put 2? Because this is a list, and when I am traversing through a list, this is 0, this is 1, this is 2, this is 3. So let's say we want to access the third element, I'll get 4 over here. So this is how we are accessing elements in an array. This is how we are indexing an array, a 1D, 2D, 3D array. This is an indexing in a 2D array. Let's say somebody says, find out second index of the second array in a 2D array. So second array is 1. First I am accessing the second element, which is 10, 20, 12 and 11. Now in this, I am just traversing through a list. So let's say 2. When I am putting 2 over here, what will I get? Answer me. In this list, if I am indexing it at 2, what answer would I get?
12.
Okay. Others? Harshita?
12, sir.
Rushmita?
12, sir.
Great. Uday, Ganesh?
12, sir.
Afrid? Afrid, you have to be interactive during these sessions. It's not a one-way thing. Okay, fine. So, you are right. The answer is 12. So the first index that I pass is the index of the array. 1D, every 1D array. So let's say we have ARR3. So let's say I want to access this element. Fine, understand now. ARR3. Now this entire thing is the first index. This entire thing is the second index. So when I put 1 over here, because first index, this will be 0 and this will be 1. When I put 1 over here, I'll get 1, 2, 3, 4, 10, 11, 12, this one. Now when I'm, let's say I want to traverse through it. So in this also now, this is a 2D array. So 1, 2, 3, 4 is the first element. So it will be index 0. I'll get 1, 2, 3, 4. Now, let's say I want to access first element of this thing. So it will be first element. It will give me 1. So that's how indexing in a 3D array works. Is it clear?
Yes.
I can explain it to you in a simpler manner on an Excel as well, that how we are traversing. If you are not clear, let me know, because this is important. Now, instead of creating these arrays, this is what we are creating on our own. We are adding values on our own. So there is something called np.arange. np.arange, let's say 5. So it will create automatically a 1D array for you with range from 0 to 5. If I want to create an array A in a range from 1 to 5, I can create it directly. It will give me the result directly. So it is basically 0 to 5. Let's say 1, 5. So it will give me 1, 2, 3, 4. Just like range, only difference is I am adding an A to it. A a range, or you can arrange it. If you want to remember it, you are arranging an array by providing it a particular range. Let's say np dot arrange, let's say 42. So I'll get 0 to 41, all the elements listed together. Let's say I want to have np dot arrange, I don't remember if that would work over here or not, 5:2. No, that doesn't work. Skip doesn't work over here. So this is how another way of creating a 1D array. You can create a 1D array using a range. You can pick up any random number and create an array for yourself. So guys, that's all for today.